Hi there, today we're going to learn about the uniform distribution. Okay, so we're going to start, this is from chapter 3, which is, we're learning a few particular distributions. And again, these are discrete probability distributions as opposed to continuous. Let's see there. Probability distribution. In a discrete probability distribution, you can list the outcomes. So we've been talking about random variables. And random variable x that this is a numerical outcome from an experiment. So we've had a few examples of that where x is the number of heads in 5 rolls, or in 5 coin flips. Many other things. Number of heads, number of green cards, all sorts of examples. And so today we're going to talk about a specific one, and it is called, all right, we're going to have a definition. It is called the discrete uniform distribution. All right, and when in the discrete uniform distribution, the experiment consists of randomly selecting one number from 1 to n. All right, so from 1 to 3 ... to n. All right. And the way we say that the random variable x, all right, so here's some notation. We say x, and this guy, this is a tilde, this whole thing there. And that tilde says when the next thing is coming is we're going to tell you what that distribution for x is. And that's what it looks like, okay? So again, this guy right here, okay, so this guy, this is my random variable, the x. This guy right here, this is called a tilde, and what it means is distributed as. Or you might think x has probability distribution, and then this, the uniform, this says I want the uniform probability distribution. And n, this thing right here, because this can go from 1 to whatever, this n here, this is called a parameter. And basically for each example, I'm going to have to tell you, well, 1 to what? Am I picking 1 from 1 to 10, 1 to 100? Am I picking 1 day out of 30 days? So that parameter, so I have to state that. So then I would fill it in like that. So for instance, an example would be, we might say that if I roll a die, all right, and then x is the roll, we might say x has a distribution, the uniform distribution, with parameter 6, because there's 6 possible outcomes. So here, my outcome for my random variable can be not 0. Starts with 1, so not 0. 1, 2, 3, all the way up to 6. Those are my possible outcomes. Okay, and so and we're randomly selecting one of those outcomes. So what does that mean? The probability for each of these rolls, so we already learned this, that this is equal to 1/6. So the probability of a 1 is 1/6, probability of a 2 is 1/6. So we learned this earlier when we were learning about distributions for equally likely outcomes. So each one of these 1, 2, 3, 4, 5, 6 is equally likely. So that means the probability is 1 over the number of possible outcomes. All right, so let's talk about a few rules. Right, for the uniform distribution. Right, one is its probability distribution, which we kind of talked about here as an example. All right, so the probability distribution for a discrete random variable, or its discrete uniform random variable, x is this. So here is a fancy way of basically saying that p for each x is 1 over n. All right, but we're gonna put this little bracket here, a big bracket. So 1 over n, this is for values, when x equals 1, 2, 3. Again, not 0. 1 to n, not 0. 0 is not part of it. And then in the probability for any other number, so for instance, the probability of 10 is 0. So it's 0 elsewhere or otherwise. So p of 1 is 1/6, or p is 1 over n. So p of 1 is 1/6. This is for our roll of die. P of 1 is 1/6. Anything else? I mean, I could say, what's the probability of rolling, 2.5? That's also 0. All right. So for these n numbers, probability is 1 over n. Okay. So it's a fancy way of saying what we already know to begin with. All right. So rule 2 is about the mean. Okay, so the mean, which is mu, this is equal to, and this is actually equal to the median as well, but the formula is n plus 1 over 2, and this equals the median. So let's go back to our example where we had our die, right? So for the roll of die, we could, if we were using the fancy way of saying p of x is 1/6, we could say it's 1/6, for x equals 1, 2, ... 6, and it's 0 otherwise. And you can abbreviate that with OW if you like. All right, so if I did a little graph of this, okay, I got 0, not 0. Keep doing it, even though I keep telling you not to do it. Okay, this is 1, 2, 3, 4, 5, 6. I'm going to my possible x's. And then over here, here's my p of x, and it's 1/6 for everybody. So it's supposed to be vertical. All right, so on my graph, this is flat. All right, so basically that's for the kind of uniform. It's uniform all the way across the graph. And if you look, if I put right between 3 and 4, if I put a little dotted line here, right, then to the left of 3.5, we've got the same thing as we have on the right side. So this is symmetric. And we have a symmetric distribution. Whenever we have that, the mu is equal to the median. The median here is 3.5. Okay. So that works for our formula. We can do that from the median, but according to the formula, mu is n plus 1 over 2. Here, n is 6. So that's 6 plus 1 over 2, and that is 3.5. N plus 1 over 2 is the median of 1 to n. Rule 3 is about the variance and the standard deviation. So the variance of x, this is sigma squared, And this formula is going to not be as intuitive as that other one, but you just have to memorize it. This is n minus 1 times n plus 1 divided by 12. So that's the variance, and recall, sigma, the standard deviation, is always the square root of that. If it asks for the standard deviation, and we want the square root of n minus 1, n plus 1 over 12. This one the standard deviation gets used a lot more, so we probably will use this formula more than we use the other formula. All right, so let's just start with that. Let's find the variance. Okay, so for our example, when we're rolling a die, we already got that u is 3.5. All right, so then sigma is going to be the square root of n minus 1. Okay, so here n is 6. So 6 minus 1 is 5. 6 plus 1 is 7 over 12. So this is equal to the square root of 35 over 12. Let's see what the answer is. It is 1.708. Right, and that's the standard deviation. Okay. So the average roll is 3.5. The spread of the roll is around 1.7. I'll measure spread. All right, so because I'm going to call this rule number 4. All right, so sometimes we want the probability of the set of outcomes here. So the probability of an event, again, we're still talking about the discrete uniform distribution. The probability of an event involving several outcomes, let's call it event A. Right? So it's going to be the probability. So the probability of A, I should write capital P and capital A. Probability of A is going to be the number of outcomes that are in A over little n, because recall the probability of each outcome is 1 over n. So, if I've got 5 outcomes, then it's going to be 1 over n plus 1 over n plus 1 over n. All right, so let's do an example. Well, if we use the rolling a die, let's say I'm rolling a die, I need a 3. So what's the probability that I get at least a 3? All right, well, that'll be, probably being a 3 plus a 4 plus a 5 plus probably a 6. All right, there's 4 of those, so that's going to be 4 out of 6. 2/3. Right, so 2/3 of the time I would get what I need if I need at least a 3. Okay, let's do a different example. Okay. Let's say that there's tickets for sale. All right, so we sell tickets for $5 a piece. And the amount you win, so you win the number that's on your ticket. in dollars. Okay, the number on your ticket. All right, so basically, you sell the tickets. So basically, so X is the amount paid, and we're selling. Oh, and we sell 500 of them. These will be numbered, 1, 2, 500. So, so X equals the amount 1. Okay. Then X has what distribution? Okay. So I've got 500 possible tickets here. And actually, this is the amount, I shouldn't say 1. This is the amount that's paid to the winner. How much? All right. So we're the ones selling the tickets. So how much are we going to have to pay to the winner? So X can be anything from anywhere from $1 to $500. And that's uniformly distributed because each ticket is equally likely to be chosen. So this is a uniform distribution. And with parameter, again, this is called the parameter. With parameter n equals 500. And this is in dollars. Okay. So our probability of each possible value is going to be 1 over 500. 4x equals 1 to 500. 0 otherwise. All right, so let's find the probability that the winner wins over $100. All right, so from our rule about uniform distributions, right? So this we would count, how many outcomes are over $100. Right? And so what would be in this list? So if I call this over $100, if I call it event A, right? So A equals, so the first value over 100 would be 101. And then 102, all the way up to 500. And so how many are there? So 101 to 200, that would be there be 100 there, 2, 3. So this is equal to 400. It's everything except the first 100. All right. So then the probability of paying winner over $100, which is going to be my probability of A here, is going to be 400 over 500. This is 4/5 of 28. All right, so let's find the mean. So, basically this would be the average payout. Right, and this is going to be mu, and from our formula, it's n plus 1 over 2. And this is going to be 500 plus 1 over 2, which is $250.50. So on average, that's what we would pay out. All right, what's the standard deviation? All right, so sigma here, this is the square root of n minus 1, n plus 1 over 12. N minus 1, that's going to be 500 minus 1, that's going to be 499. And plus 1 is 500 plus 1, that's going to be 501, and 5 by 12. 499 times 501, 5 by 12. And let me take the square root here, and then it's 144.34. Dollars, so $144.34. Now here is an interesting question, right? Something we haven't looked at before. What is the average amount? All right, so let's say that we will raise. And recall, we're going to sell these tickets for $5 a piece. So we want the average of X here. So we don't want U, all right? We don't want the expected value of this is the payout. We want the expected, this was the expected payout, that was the $250.50. What we want is the expected amount raised. So what is the amount raised? So the amount raised, well, we would sell 500 tickets times $5, so that's going to be 500 times, that's going to be how much we bring in, right? This is going to be our revenue, you know. Right? And then it's going to be minus the payout. And that's X. So 500 times 5 minus X. So there's some formulas for calculating the means of the other things. All right, so if E of X, so here's the rules. So we got, the expected value of X, the average X is mu. Then we have some rules for what if I want, instead of X, I want 2 times it, or I want X plus it. So basically, the expected value, if I take a constant times my random variable X, this is going to be, just take the constant times it. Constant times the mean of X. Right? And if I want the probability, I want to add something to it or subtract something from it, or, I'm going to take X, plus a constant. Well, this is just the expected value. This is just the average X plus the constant, right? So here, if I multiply by something, I multiply by that constant, and here I'm adding something. So here, I'm multiplying something times X here. We don't usually write it, but the coefficient of X here is -1, right? So the expected value of 5, this is going to be the expected value, 500 times 5 is 2,500. Right? So the expected value of minus X is going to be minus mu. And then we're adding 2,500, even though I didn't put it that this is the same as saying E negative X plus 2,500. All right, so then so this is going to be 2,500 minus the mean. So, so my average amount we raise is $2,500 minus the average payout, which we said the average payout was $250.50. All right, so that's going to be $2,200, $2,249.50. And this is the average amount of we raise. Right? We could, if the person who got the $500 ticket won, then our payout would be $2,500 minus $500. So we would only pay out, our earnings would be $2,000. And if somebody won the dollar ticket, then we would make $2,499. So, but on average, this is what we make if we were to use this fundraiser over and over again. On average, we should win, or we should make $2,249.50. All right, so let's use our empirical rule here. Call this according to the empirical rule, then over 90% of the time, X, which is our payout, will be within 2 standard deviations of the mean. And recall here, our mean was $250.50. And our standard deviation that we calculated, let's see, what was that? That was, yeah, yes, $144.34. So what's the probability that we're within 2 standard deviations of the mean? All right, so if I calculate U minus 2 sigma, I'm going to have $250.50 minus 2 times $144.34, and that's going to be negative. All right, that's going to be let's calculate it. So, got 250.5 minus 2 times 144.34. There it goes. Minus $38.18. If I take mu plus 2 sigma, $250.50 plus 2 times 144.34. Plus 2 times 144.34. That gives me $530.18. So according to the empirical rule, most of the time we will make over a negative amount and less than $539. So what's the actual probability of being within there? Well, the possible values, so if you do a little number line, here's, this according to my rule would be, somewhere from negative $38 to positive $539. I just rounded. But my possible values are, I've got from 0 to 500. So what's the probability? Not 0, 1 to 500. From 1 to 500. So everything is in between 1 and 500. So this probability is 1. So normally, most distributions, I have to go out 3 sigma to get there. But for this one, I went out 2 sigma, and I got all of my observations. So that's unusual, but this is kind of an unusual distribution.